UPS system can indeed be sized based on the actual load rather than relying solely on nameplate ratings. Nameplate ratings typically represent the absolute maximum power a device could potentially draw under the most extreme conditions. However, in normal operation, the actual load is often significantly lower. Sizing a UPS based on the nameplate can lead to oversizing, resulting in unnecessary expenses, increased space requirements, and potentially lower efficiency. To accurately size a UPS, it's essential to determine the actual power consumption of the connected equipment. This can be achieved through various methods, including power monitoring, load testing, and utilizing power management software that provides real-time power consumption data. Power monitoring involves using specialized equipment to measure the actual current and voltage drawn by the IT equipment over a period of time. This data can then be used to calculate the actual power consumption in watts or volt amps. Load testing involves simulating the expected operating conditions of the IT equipment and measuring the power consumption under those conditions. This can provide a more accurate assessment of the actual load compared to relying solely on nameplate ratings. Power management software can provide real-time power consumption data for individual devices and entire systems. This allows for continuous monitoring of the actual load and provides valuable insights into power usage patterns. By accurately assessing the actual load, you can select a UPS with the appropriate capacity to provide adequate backup power without oversizing. This will result in cost savings, improved efficiency, and a more optimized power infrastructure. Now let's delve into National Electrical Code Article 645.5 concerning branch circuit conductors. National Electrical Code Article 645.5 addresses the requirements for branch circuit conductors serving information technology equipment rooms. Specifically, it refers to the connected load when determining the appropriate ampacity of the branch circuit conductors. The term connected load as used in the National Electrical Code can sometimes be ambiguous, leading to questions about whether it refers to the sum of the nameplate ratings of the connected equipment or the actual load. While the strict interpretation of connected load might suggest using nameplate ratings, a more practical and efficient approach, especially in the context of IT equipment rooms, is to consider the actual load or the maximum expected load. Using nameplate ratings alone can often result in oversizing the branch circuit conductors, which can lead to increased costs and inefficient use of materials. In many IT equipment rooms, the actual load is significantly lower than the sum of the nameplate ratings due to factors such as power management features, equipment utilization rates, and diversity of loads. Therefore, it's generally recommended to use actual load data or the maximum expected load when sizing branch circuit conductors for IT equipment rooms. This approach ensures that the conductors are adequately sized to handle the actual current draw of the equipment while avoiding unnecessary oversizing. To determine the actual load, you can use the same methods described earlier for UPS sizing, such as power monitoring, load testing, and power management software. By accurately assessing the actual load, you can select branch circuit conductors with the appropriate ampacity to meet the requirements of National Electrical Code Article 645.5 while optimizing cost and efficiency. It's important to note that the National Electrical Code also requires that the branch circuit conductors be protected by overcurrent protection devices, such as circuit breakers or fuses, that are sized appropriately for the ampacity of the conductors. This ensures that the conductors are protected from overload and short-circuit conditions. In summary, when sizing branch circuit conductors for IT equipment rooms, it's generally recommended to use actual load data or the maximum expected load rather than relying solely on nameplate ratings. This approach ensures that the conductors are adequately sized to handle the actual current draw of the equipment while optimizing cost and efficiency. Always consult with a qualified electrical engineer or contractor to ensure that the electrical system meets all applicable codes and standards. To ensure an efficient and safe IT equipment room electrical design, consider these key factors. Firstly, conduct a thorough load analysis. Accurately determine the actual power consumption of all IT equipment to avoid oversizing and ensure efficient operation. Secondly, consider redundancy and scalability. Design the electrical system to accommodate future growth and provide redundant power sources to minimize downtime. Thirdly, implement power monitoring and management. Utilize power monitoring systems to track power consumption and identify opportunities for optimization. Fourthly, ensure proper grounding and bonding. Implement a comprehensive grounding and bonding system to minimize electrical noise and ensure equipment safety. Fifthly, provide adequate cooling and ventilation. Maintain optimal temperature and humidity levels to prevent equipment overheating and ensure reliable operation. Sixthly, comply with all applicable codes and standards. Ensure that the electrical system complies with the National Electrical Code and other relevant regulations. Seventhly, use energy-efficient equipment. Select energy-efficient IT equipment and power distribution units to minimize energy consumption and reduce operating costs. Eighthly, implement surge protection. Protect IT equipment from voltage surges and spikes with surge protection devices. Ninthly, provide backup power. Install a UPS system to provide backup power during power outages and prevent data loss. Tenthly, perform regular maintenance. Conduct regular maintenance on the electrical system to ensure optimal performance and prevent equipment failures. By implementing these best practices, you can design an IT equipment room electrical system that is efficient, reliable, and safe. The topic of accurately sizing UPS systems and interpreting National Electrical Code Article 645.5 is crucial for ensuring the efficient and safe operation of IT equipment rooms. By understanding the differences between nameplate ratings and actual load, and by applying appropriate engineering practices, it is possible to optimize the design of electrical systems for these critical environments. Remember to always consult with qualified professionals and adhere to all applicable codes and standards to ensure the safety and reliability of your IT infrastructure. Let's talk more about power distribution. Power distribution within an IT equipment room is a critical aspect of ensuring reliable and efficient operation. The design of the power distribution system should take into account the specific needs of the IT equipment, the available power sources, and the overall goals of the organization. One of the first considerations is the type of power distribution system to use. Common options include rack-mounted power distribution units, or PDUs, overhead busways, and underfloor cabling. Rack-mounted PDU are a popular choice for IT equipment rooms because they provide a convenient and organized way to distribute power to individual servers and other devices. PDU typically include features such as surge protection, remote monitoring, and individual outlet control. Overhead busways offer a flexible and scalable solution for power distribution. They consist of a series of interconnected busbars that are suspended from the ceiling. Tap boxes can be installed along the busway to provide power to individual equipment racks. Underfloor cabling is another option for power distribution. This approach involves running power cables under the raised floor of the IT equipment room. Underfloor cabling can provide a clean and organized appearance, but it can also be more difficult to access and maintain. Regardless of the type of power distribution system used, it is important to ensure that it is properly sized to handle the expected load. This involves calculating the total power consumption of all IT equipment and selecting conductors and overcurrent protection devices that are rated appropriately. It is also important to consider the potential for future growth and to design the power distribution system to accommodate additional equipment as needed. In addition to sizing and capacity, power quality is another important consideration. IT equipment is sensitive to voltage fluctuations, harmonics, and other power disturbances. To ensure reliable operation, it is important to provide clean and stable power to the IT equipment. This can be achieved through the use of uninterruptible power supplies, or OPSs, power conditioners, and harmonic filters. UPS provide backup power in the event of a power outage. They also protect IT equipment from voltage fluctuations and other power disturbances. Power conditioners filter out noise and harmonics from the power supply. Harmonic filters reduce the levels of harmonic distortion in the electrical system. Grounding and bonding are also critical aspects of power distribution in IT equipment rooms. Proper grounding and bonding helps to minimize electrical noise and prevent equipment damage. The grounding system should be designed to provide a low impedance path for fault currents. The bonding system should connect all metallic parts of the electrical system together to create a common ground reference. Regular maintenance is essential for ensuring the continued reliability and efficiency of the power distribution system. This includes inspecting conductors and connections, testing over current protection devices, and cleaning equipment. A well-designed and maintained power distribution system is essential for ensuring the reliable and efficient operation of IT equipment rooms. By considering the factors discussed above, you can create a power distribution system that meets the specific needs of your IT equipment and supports the overall goals of your organization. Let's dive deeper into UPS systems. UPS systems are critical components of IT infrastructure, providing backup power during power outages and protecting sensitive equipment from voltage fluctuations and other power disturbances. Understanding the different types of UPS systems, their key features, and proper maintenance practices is essential for ensuring reliable operation. There are three main types of UPS systems. Firstly, online UPS, secondly, line interactive UPS, and thirdly, offline UPS. Online UPS provide the highest level of protection. In online UPS, the IT equipment is always powered by the UPS inverter, which converts direct current power from the battery to alternating current power. The utility power continuously charges the battery and provides power to the inverter. During a power outage, the inverter seamlessly switches to battery power, providing uninterrupted power to the IT equipment. Line interactive UPS provide a balance of protection and cost-effectiveness. In a line interactive UPS, the IT equipment is normally powered by the utility power. However, the UPS continuously monitors the utility power and automatically switches to battery power when voltage fluctuations or power outages occur. Line interactive UPS also include features such as automatic voltage regulation or AVR, which helps to stabilize the voltage supplied to the IT equipment. Offline UPS provide the lowest level of protection and are typically used for small offices and home offices. In an offline UPS, the IT equipment is normally powered by the utility power. During a power outage, the UPS switches to battery power, but there is a brief interruption in power as the switchover occurs. The key features of UPS systems include power capacity, battery runtime, surge protection, remote monitoring, and automatic voltage regulation. Power capacity is the amount of power that the UPS can deliver to the IT equipment. It is typically measured in voltamps or watts. Battery runtime is the amount of time that the UPS can provide power to the IT equipment during a power outage. It depends on the power capacity of the UPS and the load of the IT equipment. Surge protection protects the IT equipment from voltage surges and spikes. Remote monitoring allows you to monitor the status of the UPS from a remote location. Automatic voltage regulation stabilizes the voltage supplied to the IT equipment, protecting it from voltage fluctuations. Proper maintenance is essential for ensuring the continued reliability of UPS systems. This includes regularly inspecting the batteries, cleaning the UPS, and testing the UPS under load. Batteries are the most critical component of a UPS system. They should be inspected regularly for signs of corrosion, swelling, or leakage. Batteries should also be replaced every 3 to 5 years, depending on the type of battery and the operating conditions. The UPS should be cleaned regularly to remove dust and dirt, which can impede airflow and cause the UPS to overheat. The UPS should be tested under load to ensure that it can provide power to the IT equipment during a power outage. When selecting a UPS system, it is important to consider the specific needs of your IT equipment, the available power sources, and the overall goals of your organization. A well-designed and maintained UPS system is essential for ensuring the reliable operation of IT equipment rooms. Let's turn our attention to electrical safety. Electrical safety is of paramount importance in IT equipment rooms, where a high concentration of electronic equipment and electrical wiring creates potential hazards. Adhering to electrical safety codes and standards, implementing safety measures, and providing proper training are essential for preventing electrical accidents and ensuring the safety of personnel. The National Electrical Code, or National Electrical Code, is the primary electrical safety standard in the United States. It provides comprehensive guidelines for the safe installation and maintenance of electrical systems. Other relevant standards include the Occupational Safety and Health Administration, or OSHA, regulations and the National Fire Protection Association, or NFPA, standards. Key electrical safety measures in IT equipment rooms include proper grounding and bonding, overcurrent protection, ground fault circuit interrupters, or GFCIs, arc fault circuit interrupters, RFCIs, and lockout/tagout procedures. Proper grounding and bonding helps to minimize electrical noise and prevent equipment damage. It also provides a low impedance path for fault currents, reducing the risk of electrical shock. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overload and short-circuit conditions. GFCIs protect personnel from electrical shock by detecting ground faults and interrupting the circuit. SIs protect against arc faults, which are dangerous electrical discharges that can cause fires. Lockout/tagout procedures are used to energize electrical equipment before maintenance or repair work is performed. This prevents accidental energization of the equipment, which could cause serious injury or death. Regular inspections are essential for identifying potential electrical hazards in IT equipment rooms. These inspections should be performed by qualified personnel and should include a thorough examination of electrical wiring, equipment, and grounding systems. Employees who work in IT equipment rooms should receive comprehensive electrical safety training. This training should cover topics such as electrical hazards, safety procedures, and the proper use of safety equipment. It is also important to promote a culture of safety in IT equipment rooms. This involves encouraging employees to report potential hazards and to follow safety procedures at all times. By adhering to electrical safety codes and standards, implementing safety measures, and providing proper training, you can create a safe working environment in IT equipment rooms and prevent electrical accidents. Let's explore cooling and ventilation. Maintaining optimal temperature and humidity levels is crucial for the reliable operation of IT equipment in IT equipment rooms. Overheating can cause equipment to malfunction, reduce its lifespan, and even lead to permanent damage. Proper cooling and ventilation are essential for removing heat generated by IT equipment and maintaining a stable environment. There are several methods for cooling IT equipment rooms, including air conditioning, air cooling, liquid cooling, and free cooling. Air conditioning is the most common method for cooling IT equipment rooms. Air conditioners remove heat from the air and circulate cool air throughout the room. Air cooling involves using fans to circulate air around IT equipment. This method is less effective than air conditioning, but it can be used in conjunction with air conditioning to improve cooling efficiency. Liquid cooling involves using a liquid coolant to remove heat from IT equipment. This method is more effective than air cooling, but it is also more expensive. Free cooling involves using outside air to cool IT equipment. This method is the most energy efficient, but it is only feasible in climates with cool temperatures. In addition to cooling, proper ventilation is also essential for maintaining a stable environment in IT equipment rooms. Ventilation helps to remove stale air and introduce fresh air into the room. This helps to prevent the buildup of heat, humidity, and contaminants. The cooling and ventilation system should be designed to meet the specific needs of the IT equipment in the room. This includes considering the heat load of the equipment, the size of the room, and the desired temperature and humidity levels. It is also important to consider the potential for future growth and to design the cooling and ventilation system to accommodate additional equipment as needed. Regular maintenance is essential for ensuring the continued reliability and efficiency of the cooling and ventilation system. This includes cleaning air filters, inspecting equipment, and testing the system under load. By maintaining optimal temperature and humidity levels, you can extend the lifespan of IT equipment, improve its reliability, and prevent costly downtime.